So good evening, everybody. For those who don't know me, my name is Hugo Mestre. I've been a developer since 2020. It's been so long that it's complicated to say, but it's been from 2000. So it's been 23 years of developing and coding, and they made me say if I wanted to say something about here in the GeekSession. So I decided to go with something that I really like, really enjoy, and I've been working lately. So today we're going to talk about MySQL JSON fields. What I feel is a perfect marriage between SQL and NoSQL. Just a question, who here works with MySQL, MariaDB, or CouchDB? First the SQL ones. Okay, and now the NoSQL ones. Okay. We know put everybody at the side, so we have the... So, what we're going to talk about tonight, like the remote. Couldn't find my own. So we're going to talk about what is JSON. Secondly, we're going to say JSON fields in MySQL. And then we're going to talk about some JSON functions. There are so many, I'm just going to approach some of them and try to see the ones that I think is better for now. The speed in indexing, this is something really very special also in MySQL. And practical examples in MySQL, let's see how this goes, because this projector is not the best thing, so I'm trying to see the code and trying to see complex queries. I don't know how is that going to show, but let's see how it goes. And a small conclusion. So, what is JSON? JavaScript object notation. One of the things is a lightweighted data interchange that can easily be read by humans, but also, and this is very important, easy for machines to parse and generate. Structure is made of a collection of name values, key name values, often called as an object, but then you have also ordered lists, they can call it an array. Also, it's language independent. It was based on JavaScript, but it's language independent, and everybody that codes usually knows this type of format, and is very familiar with the conventions. And use cases usually used for JSON. So we commonly use it for transmitting data with web applications, between server and client, but also for configuration data and storage. So this is a small example of a JSON file, and the one that we're going to use in our examples. As you can see, we have an email, a profile that has a name and a height, then we have a user ID, username, and then favorite movie. So we have Mr. Luke Skywalker, then we have the title of the movies he was in, and then we have his user ID and the height. This was totally invented. I do not know the height of the persons and everything else. This was all produced by a script. Continue. JSON fields. So this happened to appear in MySQL version 5.7. This was in 2015 that we started first to have JSON fields inside MySQL. But one of the things that we can do now is we can query, update, delete, and index those JSON fields. And also, have a powerful JSON field type and JSON functions that we're going to see. It's essentially, that's why I called it marriage, because it was a 500-mile trip that I did, and Humberto was telling, you have to have a name. And this was the name I got after I was very, very, very tired. So essentially marries the benefits of SQL and NoSQL, allowing the structured query and abilities on a non-structured or semi-structured data. Key aspects that I want to talk about. So, native data type. This is very important, and this is a very distinct thing about, for example, MariaDB. That's a very common thing, a fork that we all use, or some people use, that is MariaDB, but there's a very big difference there. The native data type in MySQL, from 5.7 to 8, it's a proprietary data type, it's a binary, and it's completely different from the one in MariaDB, that it's an alias for long text. So this is a big change and a big difference that we have, for example, from these two. But I'm not here to talk about the differences between them, just talk about the other one. So for example, store JSON documents in MySQL tables. I think this is something we want to do. And use the SQL to query the JSON data, including nested objects. And we know that JSON can have a lot of nested objects, and sometimes it's very complicated. And then manipulation. We can now manipulate completely JSON directly in the database. Another difference there is between MySQL and MariaDB is that the validation in MySQL is done automatically. So because this is a native data type, what means is that whenever you try to insert something to the JSON data type, you will be valid or no valid. So it will return null if it's not valid. In MariaDB, you can't do this. You have to have a function to do a check on the JSON field. So, why JSON fields in MySQL? Schema flexibility. This is something that I think everybody that works with databases usually has. So we have a big database with a very complicated schema, and now somebody says, well, we would like to have a configuration for this widget, and we'd like now to have, for example, the colors for each user or something. And sometimes to do this in a relational database is very complicated. So you would have to add new columns, you would have to make a very big migration to change all you want to change. But if you put it in a JSON script, in a JSON data type, it's going to be a lot easier. Of course, if you want to change something inside all of the data, you can. You have stored procedures, triggers to change, or you can have a script that can change everything. But it's quite different than doing a big migration with some big change, like adding new columns. Imagine like very big database, and then we say, well, we're going to add 2 new columns. Well, that's going to be complicated, especially if you don't have all the resources to have, for example, 2 servers to do the same thing and then do the change. So this is one of the things that I think is very good on JSON data fields inside MySQL. Data consolidation. Enable storage, multi-structured data in a single field. It has atomicity, consistency, isolation, and durability. So ASIC. This is the main focus of what we have in a relational database. Enhanced query abilities. So we can have now the power of SQL to have complex queries inside our JSON data. Some of the JSON functions that we're going to talk today, for example, like the JSON extract. Then you have also that inline path operator. That it's the hyphen with the 2 greater than errors. Those are the something that is exactly the same thing as JSON extract. They have a JSON column, same thing. JSON and quote contains. I'm going to show this in the code, so I'm just going to say which ones we're going to talk about. JSON search, JSON insert, JSON set, array append, array insert, array object, array aggregate, and object aggregate. There's a lot of discussion in the internet right now that people are leaving the group concat and now using these 2 functions to do concatenation between whatever you want to do in your data. Group concat still has a lot of things that you can't have like this, but these ones are really good and really powerful and a lot quicker. And of course, JSON table. This is the one that I like the most because it can transform a JSON object into a relational database almost. And I'm going to show you some examples so you can see exactly what we're talking about. Another thing that is very important is speed and indexing. MySQL does not try to compete with NoSQL databases. This is not what is intended to. The idea behind this is for you to have the power of JSON, and you'll be able to iterate through a JSON object, being able to add, to extract and work with it. And the idea is not to have speed like a NoSQL database. For that, you would have a NoSQL database. We have to adapt to the better tool for our job. In this case, if you want to have a reliable, in this case, relational database, and we want to be able to create new structures easily, JSON is a good thing. But we have indexing. And one thing we can't do is directly index a JSON field. So we can't really, for example, we have a complex JSON inside one of the columns, and we want to index for one of the properties there. That can't be made. So in this point, we cannot do indexing. But we can is generate from that data a new column, and that column can be indexed. So I'm going to show some examples with our data to see, for example, how can we index some table and we can present them to the user. So just as an example, what we would do if you wanted to add a column, so easily as alter table, the table would be activity log, add a column email, and it would be generated always as properties request email. That $request email is the path in our JSON. So this means that every single field that would have being introduced, it would create automatically a new column. But the column would be already created, sorry. It would populate the column with data that is fed from that JSON data. And this is very important because it enables you to be able to index and get a little bit more speed out of it. And let's see how this is going to people now. Okay, so looking at the data, I'm going to show this again because I think. Can you read this from the kind of? Okay, so we have like 20 rows inserting this database, so all regarding like this. So we have Luke Skywalker, Anakin Skywalker, all of those great characters in Star Wars, and we want to do something with this data. So what do we want to do? Multiple functions. Okay. Not going to use it. So the first one, I don't know if you can see it, but we have two columns. One column, I think here to use this, is going to be ID, that is automatically incremented, so it's an automatic incremented number. Then we have user data, that's the JSON field. So we have a big JSON here, and this is the one that we're going to start using. So one of the things that we can do is extract data from that field. So for example, if we wanted to extract the profile name, we would just simply do user data, this one, so the hyphen in the greater than is called the path, and profile.name. And what this would do, okay, much bigger. Okay,
that's the force.
You can see it, huh? Okay. This is okay.
Too big now.
It's really big because now it's okay. So the extracted name, as we can see here, because it's using just the hyphen and the greater than, is showing the name, but it's showing with the double quotes. But if we use the two ones like this, what's going to happen is it's going to unwrap. So it's going to unquote the name. So we have like Luke Skywalker, Princess Leia, and all the other ones. So then, if we continue here, and let me get this bigger because I think this one can get bigger. Yes. We have also something that we can do that is JSON unquote. This is exactly the same thing but using two functions. So one function is going to be extracting the data. In this case, I'm going to remove the profile, well, re-extract the profile and the name, and then I'm unquoting it. So this is the unquote name. So it does exactly the same. Then we have something very cool that is JSON search. Then we have, this is going to be a little bit more tricky because it has, first, you're going to use or say which column you're going to have the data. In this case is user data. And then we can say all or one. And what this does is it says if you want to stop in the first appearance of what you're searching, or if you want to have all the, and it is going to retrieve the path. It's not going to retrieve the value, but it's going to retrieve the path where it's found that element. So for example, here you see that we don't have, let's see if we can see it a little bit better. But for example here, I was searching for Yoda, and it found Yoda. This was where it found it. So the path was profile.name. So it found Yoda there. But for example, I have another one here that is, for example, Skywalker. So I'm going to search in the whole JSON. I'm not going to say which path I'm going to search. This is the whole JSON. It's looking there. And I want to say I want to search for all Skywalker. So terminated by Skywalker. We have that the percentage. So that means that everything that ends with Skywalker, I'm going to search for it. And let me move this a little bit to the right. Skywalker. So none of them have Skywalker, but then we will find one that will have two entries. Because this is too quick, let me see if here. So here, Anakin Skywalker, as you can see, it found the profile name, but it also found one of the favorite movies because he also likes one of the movies that has the what was the 9 movie from the Star Wars? The last Skywalker, bad film. Okay, that's why I don't know the name. But so this is the difference between one and all. So if you play one, it will stop immediately when it asks or it finds the what it's searching for, so the needle, and it will show the path where it found it. Another cool stuff that we can do. We can do things like, for example, this. So we can do a if statement, and we can do is if we have a JSON search user data, only one reference, so I want to stop at the first reference we have for the Empire Strikes Back. If it has the Empire Strikes Back, what it will do is saying yes. If it doesn't, no, boo. And what this does here, as you can see, put a little bit. So all of these ones they have yes, and then the ones they have no, no. It's because they don't have it on their favorite movie. So this is one of the things that you can also do, and that is very important, is that you can then access to all the functions and the string functions, and can put it JSON functions with SQL functions, whatever functions you have, you can work with it. So this is another one. Let's see. So we can do also JSON objects. This is just creating a new JSON object. We also have JSON arrays. So JSON arrays, what it was going to do is create an array out of the data that we're going to have there. You can be more complex, so you can get it a little bit more complex. I just added this one because it was for test purposes, but you can see here. So the object is here, and the array. We can also do things like, for example, we can insert into the JSON data that we have there. We can have like JSON insert user data, and we're going to say that I'm going to introduce a new path that's going to be called profile age, and I'm going to say 40, and I'm going to introduce it. That means that it's going to introduce in every single one the 40 as the age. And this one, profile age new, this is going, for example, if you wanted to use some kind of function, like logical function, you can use like a floor and randomizer, and you can do everything you want, use all the functions available in MySQL. This also works in MariaDB. The main issue here is that it's a little bit slower if you have big data or big JSON. Okay, continuing. Another thing we can do is remove a path from the JSON object. That would be JSON remove. We can replace it, JSON replace. We can set it, so we can say that the path now has this value, and this is profile age and set age. Then we have, for example, we can have the JSON keys. If I go here, and we have JSON keys, so we can see all the JSON keys that we have. If we go here, open new viewer, it moves to the other screen, which is nice. But it's here. Email, profile, user ID, username, and favorite movies. So it's just going to get the first one, not the nested ones. For that, we would have to do something different with the nested objects I'm going to show you in a bit. So array append, array preserve, that's going to say is going to preserve the array and going to append something. And JSON type, so it tells you, this is nice. Where is it? I lost it. Ah, it is. This is the JSON type. So here's if it is an object or if it is an array. So this is also very, if you want to do like, whenever you want to put the JSON data and trying to see, am I going to change an array, am I going to change an object? This is also very easy to do. You have also JSON pretty. That makes, so you can see it is a little bit prettier. Because what it does is it indents things and makes it on the different rows, so it's a little bit better. And you can, one of the good things about this is you can directly, if you're using any type of API or something that gets a response, then you can put it directly into the browser to the client, because this is valid JSON. So as long as you have it as way, the API, the microservices or whatever you have there, it will accept this. Another part, JSON contains. So it does a new contain. If this case is, you will have a path and you will see if that value happens to exist in that path. Also have JSON depth. So this is nice because then you can see how big our JSON data is. For example, we can see also first movie title is this one. So for example, I can directly go and extract one of the paths that we have. But also, we can also JSON valid. So this is to check if the JSON is really valid or not. And JSON extract already talked about. And these are the main functions that we have using them. The main functions for trying to manipulate JSON data. Now, going for another one that I like very much. Let me see if I can get this one. Yeah. Maybe 20 was too big, but okay. Let's see if I can get this. Or better yet, let me do something. Let me. See, I can put this because the. Okay. Bear with me just a second. SQL is okay. I think this is a little bit easier to read. Okay. So this is using JSON table. You remember when I said that JSON table enables us to get some object, JSON object, and then interact through that JSON object and create like a tubular or tabular data. So for example, you all remember the data that we had. So we had like username, and then we have, for example, favorite movies. And one of the things we can do is we can join, and this is how it works. We join the JSON table, and then we say what's going to be our data from. So we have a column that has the data. This is going to be user data. Then we're going to say the path that we're going to initially look for, and we're going to create some columns. So this is like creating a new schema for that data that exists on the JSON. And what we do is we say that we're going to have a username, and then we're going to have a nested. Nested, it means that it's going to get through all the options that we have in the array and put it as a different row. And it's going to get the favorite movies. And this is going to be a title and a release year. And we have to identify it exactly as we would do to create a new schema in MySQL. So we're going to have to say varchar 255, and then we say the path where it belongs to. We say that it's $title. Or for example, it's going to be an integer, and it's going to be the path release year. So if we do this, and if we go to MySQL again, and we do this, it will give us, so the username will give us the movie. In this case, it's going to be a CSV because I said it was going to be a CSV. It's going to be a comma-separated name. It's going to have all the favorite movies from that person, and then going to have also total and the object. And that's because I'm leaving this one. Trying to show you how I've done it. So what I do is JSON and quote, simple. And then I do a group concat, and this is to see the difference between group concat. And remember when I was talking about the JSON array aggregate, and you also have the JSON object aggregate. So if I do something like a group concat, the movie title and order it by movie title, then I have all the movie CSV. Then if I have a JSON array aggregate, what it's going to do is I'm going to say, I want the movie title, and all of these movie titles are going to be inside an array. And I'm going to call it movies array. JSON object tag is going to be movie title and then movie release year. And this is what's going to happen here. Shows here. As you can see, it goes as an object and it has the name of the movie, and then it has the the year it was released. More themes. The JSON path, this is a little bit complicated because I wanted to be a, if it was a little bit bigger, it's easier for you to understand all the nuances and the changes that the JSON table can do, because it's very powerful. And if you have a very big and complex JSON object, you can just simply join and say whatever you want from that complex object, and you can put it as a column and do whatever. Maybe I'm going to talk about a little bit more is how to index the files. And what we do is, so we're going to create a new table. It's going to be called users indexed. If I, what's happening? Why table already exists, of course. No, it doesn't exist. So why didn't you like it? Give me a second, always good. When things don't work at the presentation. Already exists, no problem. We create it with a new name. Clear. So what we've done is create a new table that is called users index new. The other one already existed. That doesn't help. What can I do? So I think it's this. Yes, it is. Okay, perfect. And what we're going to try to do is to do what we're said in the slide. So we're going to create some new columns so we can index them. This is going to be okay. Is it yes? And okay. We have created. So one of the things that we want to do is now introduce to our new table, new, everything that we have in the users. So we're going to introduce this one. I'm just going to insert, perfect. So now our users index 1 has every single data that we had on our users table. And what we're going to do now is change, and we're going to add two new columns. One is going to be username. So add a column called username that is going to be generated from the user data username. And we're going to add another one that is going to be user ID, and it's going to be generated always as user ID. So we can do this, and we just run. But I don't want index new. Okay. So now we have two new columns that is going to be username and user ID. And now we're going to add index as we would normally do in the working. So we can do this, but remember that it's called u. And there we have it. But we also wanted to do, and so for example, I'm going to do the following. So if we do, let's go to, difficult to write and look backwards and write properly. Okay. No, didn't like it. Okay. Are you back? No? I don't want to save. You know what I'm going to do? What I should have done. Sorry for being like this. Much better. I can see the screen also. So if we do something like from users, yes, index new, Could be. Could it be that? I don't think so because. Yeah, it is. Yeah. Why is it not showing this part? Because it was showing here. I do believe so. So let's see. We're going to do something different then. So if the autocomplete magic doesn't like it, we're going to. Okay. Users. Who would know this hour? Yay! It was exactly, the autocomplete was messing it up. So here now we have the ID, user data, and then we have the username and the user ID. So these are two new columns that were created, and they are now completely generated automatically as soon as you. And if we do something like, for example, is indexed, and we go here and we say that we want, for example, to insert a new value. And this new value that it's here, so it's going to be Indiana Jones.
New.
Thank you very much. This is why pair programming is good. And let's come on. Yes. It's not going bad. Okay, it worked. Okay, we added it. So if you go here again, I think yes. And now, what it is. And then we have now Indiana Jones. It was automatically. So we only inserted the JSON document, and the JSON document that was exactly as the other ones. It has a fictional character, username, ID, all those things, but these two columns, they were automatically created. And they are now indexed, so if you do something like select, where, for example, let's see if this does match, where, for example, the user ID equals 23. And we do something like this, and it will go and find the other ones. And if we do an explain, you will see that it will use the next key. And this is the good thing about this is that you can have very complex. And for example, in my line of work, what we do is we have a lot of configurations for columns, or we have a lot of configurations for widgets. And if we want to do something, for example, like presets, or we want to have something from the JSON that is too complicated, but we want to search for it, and they're going to say, well, are we going to search into a JSON field every single time? No, what we do is create a new column, and it's automatic generated when we insert the data, so we can index it, and then we can search for it. And this is a much quicker way to do things with JSON.
Can you show us the insert again, please?
Yeah. The insert was, if I'm not mistaken, it uses indexed. Yes, here. So the insert, this is the JSON. What we do is just add the user data because the other field was auto-incremented. So what it does is add this JSON. It validates it completely, automatically. It's one of the things, if it wasn't a valid JSON, it wouldn't go on. Something that in MariaDB you would have to do it manually. But then, just add it, and it's done.
Thank you. Does that kind of synchronization exist when you edit the fields?
It
Either
does.
the column or the JSON?
It does. And time is running out, but I want to just show you again. So if I go to here, yes. Now let's go to the parts. Every single. Okay. Yes. So as a conclusion, so MySQL support for JSON combines SQL's ACID compliant transaction. And this is very important when we're using MySQL, is that you have transactions. You have the reliability of a database of this kind that is a little bit different from the other databases, from NoSQL ones. And we can then enable structured data into semi-structured data. So this is why I call it a marriage that ensures data integrity, adaptability, optimizing the complex and evolving data scenarios within a single robust database system. This is not to, how do I say, now we're going to move from NoSQL to go to MySQL. No, it doesn't make sense. This is exactly, if you wanted to have some flexibility and you wanted to have some JSON fields inside, now you can have it and you have powerful tools to work with it. And this is the main goal, I think, that we can talk about it. And with this, I conclude my presentation. I hope you like it. Sorry for the small problems.